Subscribe now.
Okay, so thanks the host for this warm welcome. And in today's session, definitely, I hope if you have understood something today, and even if you did not, you are probably going to learn something new today as well. And even if you do have experience in this field, like building a ground control station, or most of you, if you do have experience in building softwares like this, even though you are still going to learn few things, and I'm sure of that. So just try to keep up with the lecture, and if you have any kind of doubts, you can again share with me. And I will in the live session, I'm going to answer your doubts as well. But with that, with keeping that in mind, let's just start the session. Yesterday, let me just pause my camera and just screen. So try to close it, you understand. And when I code on any VS Code or any kind of editor that you are familiar with, you just have to code with me. How are we supposed to convert the data from bytes or even from the frequencies to bytes or something in a format that we can read as a human? In today's session, we are going to talk about that. In just a second, there are a lot of things happening on the ground, and you, as a ground control station lead or as a member of the GCS team, you have to handle those problems very carefully, so that you just don't mess up in most cases, right? Now, let me tell you what are those problems. Let me take another example. This was the rocket. Again, apologies for drawing, but it is pretty decent, right? And this was the rocket, and this is our ground control station. So let me tell you, every second, every few seconds, or most of the cases, every second, like most of the completion requirements, they say that you have to transfer or receive the data from the GCS or to the rocket at a rate of 1 hertz. You know what this means? You have to receive 72 bytes of data, approx 72, and it depends upon how many sensor values you do have. Let's say you have time, you have altitude, you have pressure, you have temperature. So this value of 72 byte can vary upon certain things. So these are merely bytes. What happens is when you receive those bytes and you're trying to keep up with the rate. So let's say you're receiving 72 bytes at the rate of 1 hertz, and also where the baud rate is set to 9600, or in most of the cases it's going to be like 15200, 115200. So this will be a baud rate, this will be the bytes, approximate bytes that you'll receive, and this is the number of, the data frequency, the frequency at which you're trying to receive these bytes. So what happens every second is basically between 2 seconds, let's say 2 to 3, between 2 seconds, just 1 second between the launch of second 2 to second 3, what happens is you get the data of 72 bytes, you have to decode the data, you're told to decode, but even before decoding, you're told to capture the data. Even before capturing, you're told to receive the data. Otherwise, how you'll decode it? So first you receive the data, that's the task of Zigbee, that's the task of the antenna, so you don't have to worry about this. But receiving the data is not the main task. After you capture the data, you have to decode the data into something that is human readable. So you're probably getting 0, 8, 1, B, 1, C. So you have to convert this in, something into like 104. So that's your altitude, and 23, so that's your temperature. Slides are not visible. I can see they're visible. So you don't have problem with the storage structure. Yeah, I haven't changed the slide. I'm just trying to focus on what I'm teaching for now, right? So you get these kind of yesterday in the previous session we discussed that we have to receive the data in bytes, and that too we have to convert those bytes into numbers, numeric values like float. Float is basically the decimal point number, the point number. So most of the cases you're going to convert this into float. What happens is if you when you decode the data, you have to there are two methods of decoding. Basically, there are two phases of decoding. In the first phase, you try to look out for the header and you try to look out for the footer. Yesterday we discussed about how you match FF and you match OX. Basically, just an example of symbols of how you look for headers and how you look for footer. This is your footer, you look for that, and this is your header, you look for that. This is the first phase. In the second phase, you try to decode every data that is basically to its level, to its value. Let's say you receive 0, 1. So 0, 1 is in the second index, or if you know programming, it's in the first index. Don't worry about that. Let's say there is some values that is some value that is after the header. So that you said that anything you receive after the header is going to be a string, and the first value that you're going to receive after the header is will be your altitude value, right? This is your altitude. So this is the second phase of decoding. And the third phase that comes after everything is you're going to convert the 0, 1 into 0, 1. Let's say B1. Let's say this value is B1. You're going to convert this into 104. You're going to convert this into a float value or a numeric value, right? So this is what we discussed earlier, but that's not what happens. That's not what necessarily happens. That's not the only thing that necessarily happens. So just in between 2 to 3 seconds, we have 3 phases of decoding. We are going to decode the data in 3 phases, and most of the thing is this thing happens in the backend, but you have your front end as well. What happens is, let's suppose this is the GC screen, right? So you have 2 ports connected. So it's not like you're just receiving and sending the data from one port. You have a rocket, you have the avionics of a rocket, and you do have an avionics of a CAN sat as well. This is your rocket and this is your CAN sat. You do have different PCBs, you do have different ZigBees. So you're probably trying to receive data from dual ports, and that too, both of the ports can receive your data. Not just receive the data, it can transmit data to the rocket or either the CAN sat port as well. Your rocket probably has a CAN sat inside, a payload inside. That payload is basically that has its own avionics. So it's trying to send the data as well. So how the backend should be capable enough of transferring the data between two different. Wait a second. Yeah. So how the CAN sat is basically how the GPC is capable of receiving and transmitting or maybe decoding and stuff of data from dual ports, and that too at the different baud rate. Suppose this is your rocket port and it's trying to receive the values 9600, and your ZigBee is coded in a way that it's trying to send the values like 115200. So you have to decode your backend in a way. You have to code your backend in a way that it's capable of handling data from dual ports, and in each of the ports it can perform operations that are bidirectional. Bidirectional means what I mean when I say bidirectional, from the GCS sending the data to the rocket and receiving the data from the rocket as well. So this thing is bidirectional. So and you have again a port of the rocket and the port of the CAN sat as well. So you are trying to receive the data and trying to send the data at the dual. Voice not clear? There are multiple protocols and Amit, and it depends upon what process you are looking for. Let's say the computer networks. In the computer networks, when we transfer the data from the front end to the back end or back end to the front end, they both follow the TCP protocol. But when we talk about transmitting the data throughout the ZigBee, so that's the different case. Okay, so everything is okay. Great, great, great. Okay. Hope you are all understanding the session as well. So if you do have any kind of doubt in between, you can just ask me. First two phases. First two phases is basically there are three phases. What happens is first you decode it. Just understand for now that there are process different things while decoding. It happens. Okay. So first thing what you do is you decode. There are three phases of decoding. First you decode. First you look out for headers and footers. Okay. Then after that you try to look out for indices. What do I mean by that? You just try to say that this is if this is the header, if this is the footer, then anything in between have different values and they are separated by commas. So the first value of going to be a certain parameter, the second value of going to be a different parameter, and the third value will be of different parameter. Let's say the first value will be altitude. Altitude will catch up bytes like 0, 1. So these are the bytes of altitude. The temperature will catch up bytes like BC. So these are the bytes of bytes received by the temperature. And the third phase is basically you convert the bytes into float. In most of the cases, you use float. Then again, this is just the first part of your backend. Even before the decoding, if you try to create a backend, what you have to think of, it's not the decoding. This is mainly the theory. But let me tell you what happens in real time. In a real application that you try to build, first you have to create. What you have to do is in the backend, first you have to create a port. First you have to assign the port. How you will do it? Basically, serial library, serial or the Py serial library that we discussed in a previous session. That on this Py serial library, we can use this blank page or a whiteboard. Okay. So I'll try to make notes. Okay, so if anything complex comes, I'm just going to use a whiteboard. At this moment, this is the PPT was supposed to be this way. So even after that, you just understand it. Okay, so blank page, blank page, blank page, blank page. No, that's not the right. Hmm. There's probably the difference in the software. Software is yeah. So I think we don't really have time to just wander around these things. So I'm just going to teach you something. Okay, so try to keep up. Try to keep up. So this is basically not the this is the theory part. We are yet to discover everything. Discuss everything further in this lecture. This is just starting. So I was trying to say that how the first part of designing the backend is not basically decoding where the data is coming from. First, you have to create an instance. You have to create something that receives your data. So how you will receive your data in the backend? You use the Py serial library. It looks out for the different ports. Let's say you have USB ports in your laptop, probably more than two plus. So my laptop is old, so I have two ports. And what happens is this is your USB port 1 and 2. These are named differently by your hardware or basically your operating system. Your operating system names different ports at a time. What you can do is, one more thing. When I say port, I specifically mean USB ports here. But there is the port change it names or the port changes its value or its meaning when we talk about front end and back end. When we are getting into the software development side, when we are trying to interact different components like front end and back end, then the value of the port changes. It's basically where in which port, basically like something like 8080, which port where the backend is hosted and at which port the front end is hosted. And you try to connect the data communication between these two ports. And as somebody was asking, we use TCP protocol. Okay. I'm just trying to tell you. Okay. So you have different ports, different USB ports. So firstly, you have to code your backend in a way that if you receive if you receive serial, first you are going to use the try and block statements. The try and accept statements. You will try to receive the serial port in your Python using the Python serial library, Py serial library. You will try to receive the USB ports, and you have to list it in a way of you already know your laptop. Okay, you already know. Just go up to the hardware and try to search for COM ports. You'll go in the settings. You'll go in the hardware. You will try to look that there are multiple available USB ports. And as soon as you are going to connect your microcontroller, you're going to receive that okay COM 11 connected. So there will be an option such as COM11. So you then get it that this is your port. This is the port number that your laptop recognizes whenever it connects to a microcontroller which has an USB. So basically the Python library in the backend, it tries to look out for the ports. And as soon as it connects to a port, and it will ask the front end. Okay, so what happens is the backend discovers a port. There is a available port COM11. You'll say, oh, great, you got a port. And then it will forward the port to the front end. And the front end will have two options. The front end will look like this. This is the port R. And again, this is a drop down option of, it has different values. Let's assume 9600. And that's called baud rate. In this scenario, what happens is the backend forwards this port, the port R, and in the drop-down option, you can see that there is COM11 connected. So you are serving the front end. You are currently seeing the front end. So your website looks like this. And the bottom down or in any kind of section, you see that, okay, there is some port connected. Then you select the port 11. Then you forward a baud rate. Then you click on this drop down. You have certain options like that you have already coded before in your front end, 9600, 115200, and 19200. These are primarily the options that we use. Then you select a baud rate, and then you select, as soon as you select the baud rate from the drop down, it gets back to your backend, and it says that the user is trying to connect COM11, the port number 11, with this baud rate. So then this basically the pi serial assumes, yesterday's session we discussed that pi serial asks for two values. First is COM, basically the port number which you are trying to connect, the USB port, and second you have to give the value of the baud rate. So you have to give this manually. But in our case, in the real scenario, when you're actually trying to build a GCS, you basically give the port number, and then in the front end, the user tries to give the baud rate, and that you receive in the backend, and you say, okay, now we have the port number. So what we are going to do is we are trying to set the port number, and we will set the baud rate that we received from the front end. Now your backend is capable enough to just connect via different ports. Let's say you have different USB. So you connect up the different USB, COM12, and this USB is forwarded to the connected port. And it says that the rocket is already connected to a port, COM11, so it won't connect. But you have another drop down as well of a CANSAT, the CANSAT port. And you have the drop down of to choose which baud rate as well. So you do the same process here as well. You try to decode you try to get the port in the front end. You say COM11, COM12 it is, and your front end, the user is going to probably send the value of a baud rate from the drop down, and it's going to connect. The backend will be connected at the port number and the baud rate. So this is pretty much the first step. I hope you understood. Let me see the doubts. Can't clear. I'm really sorry, guys, if I don't understand the language. I can see some of the comments. I cannot really understand them, so understand these things. So please use a blank page. So is it getting really uncomfortable for you to understand this way? बिल्कुल नहीं समझ आ रहा. Okay, okay. Let me try once again to some extent. Let's see. What happens is, let me tell you. Let me break it down once more. What I was trying to say is, this is your front end. This is your back end. Back end is basically, it looks out for ports. It looks out for ports, and it can handle the data, etc. You know, try to explain with pictures. Surely in the I was trying to explain the simplest concepts before, since this is something that you'll struggle with the most. You can ask for front end, you can ask any kind of AI for the front end, any you can ask any kind of the anti-gravity or basically the cursor to create your backend. That won't be necessarily a problem. The problem is going to be how you will decode it, how you will even look out for the errors if you don't really know the basic terms. Terminologies in the case of understanding for yourself, that let's say you mean something else by front end, you mean HTML, CSS, and that's stuff like that. But when you prompt AI, that there might be a chance that it does not necessarily understand the front end. When you say front end, it understands that the front end for the USB. So it will understand USB interface. So it will try to code out the backend. You have to understand the terminologies in a way that you can prompt the AI at least. Since just a 2 hour session or just a 4 hour session is not necessarily enough for you in any kind of way to build a complex software as from scratch just by yourself. Obviously, you're going to need different AI tools. Whatever I'm trying to teach here are just the fundamental principles, are just the software building by first principle. I'm trying to give you out the factors where you will struggle the most. That's it. That's the purpose of this lecture. So I'm trying to tell you that what is GCS, how it works, what kind of errors you are going to counter. Since I have already built one, so I know what are the problems that you have to look out for, and where you will keep struggling trying to build one. And lastly, in this lecture, I'm going to give you a simple guide, a step-by-step guide on how you can utilize the powers of AI or basically any kind of AI tools in your terms. So I'm probably going to build a new GCS in just merely 2 to 3 hours, and it depends upon your goals and your specifications. Okay, so I'm just going to clear out everything else. What I meant that just understand the simple thing. You have a front end, basically your UI, you have a back end. It is trying to currently look out for the ports. The first thing that happens is you have to prompt your AI is to build something like that looks out for ports. So it will look out for ports, USB 1 connected, USB 1, USB 2, right? This is what you try what your AI is trying to do. So basically, this is your backend. What the backend will perform, the first action that your backend is going to perform is probably looking out for the ports, and then forwarding the port to the front end. It will say, okay, the user connected a microcontroller. I can see that the user connected a microcontroller. Can you select that what the microcontroller is going to be for the port of a rocket or for the port of the CAN? Yep. It's helpful for a second year as well. So let's say this is how your front end look like. Okay, it's a clear screen. So I hope you'll understand. This is some graphs, some crazy kind of graphs going up and down, and this is your 3D vector of the rocket is trying to move up and down. These are the sensor readings and stuff. But they won't update until and unless you connect to a port. So you have in the drop down options, you have this as well. Doesn't it look good? Like I'm getting good at drawing, right? So yeah, this is the rocket port and this is the baud rate. This is the CAN port and this is the baud rate. These are all drop down options. As soon as the backend discovers, okay, the user connected a microcontroller at port number 1, so the backend is going to say to the front end, hey, I just discovered a port. So you go here, you'll try to see that the rocket in the rocket option it says COM11, in the CAN option it does say COM11, but you know that which port of the rocket or the CAN deserves COM11. Let's say COM11, the microcontroller was coded in a way to receive or send the values to a rocket. So you're going to connect this COM11 to your rocket, and you as soon as you connect it and you set the baud rate from the drop down to a value, the front end will say to a backend, okay, I connected this port, I connected the COM11 that you discovered at the rocket port, and I set it the baud rate at 9600. Would you be okay with that? And the backend says, great, I know. So finally the front end and the back end, the connection between them is established. So the connection between them is established in a way where they can finally transfer the data between and understand each other's data. Understood? Arduino in so it's like Arduino in anyway. Yeah, it is like Arduino, the microcontroller, right? So I hope you got it. So whoever was saying समझ नहीं आ रहा है, please can you confirm? Last bit. So just the few simple steps. Your backend says, I got a port. Okay. Your backend says somebody connected a USB inside your laptop. And the backend says, okay, let me search for which USB. And it says COM11. The name of the USB is COM11. And it tries to tell the front end, hey, somebody connected COM11 to your laptop. And the front end says, okay, I'm going to choose. And the user, this is the work of a user. User will manually go and click the options will see here. The options will be visible at the rocket and the CAN port as well. This is something that you have to code in the GUI. This is the part of the GUI. So you have to code it in a way. Okay, you have to code for drop downs. You have to look for something if you received from the backend as well. Okay, so this is how you will code your front end. So the user goes up in the website and says that, okay, I'm going to convert, I'm going to just select this COM11 to the rocket side, and I'm also going to set a baud rate. Baud rate is really necessary. You know, the in the last session we try to understand the synchronization problem where the two systems that were trying to talk in basically different speed, like your friend, you're trying to talk to your friend who speaks a different language and you're trying to learn that language and you cannot really understand that language really fast. So you say that your friend says things very fast and very clear, so you won't be able to understand it. Until and unless you are both talking at the same pace, you are probably going to understand each other what the other person says. So that is the synchronization problem. So you have to be careful, really careful about the baud rate. So you forward this baud rate into the backend, and the backend says, okay, I got it. You're trying to connect this COM11 to the rocket port with the baud rate of 9600. That is the only three values that your backend receives. And your backend establishes the connection with the front end. That is what I'm trying to say. If you do not get it, don't worry about it. We are going to discuss it further in the lecture as well. It's already been 30 minutes long. Don't worry. Briefing, code survival skills. So in this session, we are going to talk about how you code the UI part. Okay, locking the UI to a rigid this screen field laptop screen. Basically, this is not going to be absolute value. Firstly, before anything else, you have to, what happens is there are few process of designing a GCS. First one is, I said it, I'm going to explain it in the last or very last of the lecture, but this is really necessary, so I think you should know it. Now, at this point, I would suggest you to take your pen and copy and try to note it. The very first point is, when you try to understand, when you try to build a GCS, when you say that how many ports you have. Ports basically how many different entities you have. Let's say I have a rocket and I'm going to have a CANSAT. In most of the cases, let's say I'm going to have a CANSAT satellite 2 and 1. So there are three different ports that I have to receive the data from. So I have to design my backend concurrently in a way that it is able to simultaneously grasp and decode the data from all these different USB ports, right? That's the first part. You try to say that what is number of ports and number of different ports. Second is, in some of the cases, it can be instead of CAN it can be a video port. Okay, you can try to receive the telemetry in the form of video. You know video telemetry, so you can receive the video from the video telemetry as well. Okay, video or camera telemetry, whatever you say. So this is first thing you have to do is look out for different number of ports and what they do. For example, Rocket is going to send me the data in form of text, I mean bytes. The CAN side is going to send me data in form of bytes, but video, is it going to send me data in format of bytes? No, not really. Then what? Pixels, right? Pixels and frames. That's what I will get from the video. Okay. So first things first is you try to look up for the port and the different formats of the port. Okay, the different data format of each port. Now you have that. You are going to discover that what kind of data, what data is it going to be? In most of the cases, you will say that, okay, so the rocket port comprises of different kind of data, such as the rocket port is trying to look out for altitude 1 and altitude 2. So there are two altitude sensors, and the rocket port is going to send us two altitude values, and is going to send us one temperature value, and it's going to send us gyro value, gyro XYZ, the roll pitch here, and then we are going to receive the acceleration. We're going to receive the acceleration in the form of XYZ and stuff, and we are going to receive the time IST format as well. So these are probably the values that we are going to receive. Got it? Then you confirm from your team avionics engineer, or if you are one, you have to confirm it that you are trying to send the data in this format only. You're trying to send the data that altitude will be all altitude 1 is going to be at the position 1, altitude 2 is going to be on the position 2, temperature is going to be on the position 3, and so on. So you have to design your backend in a way that is proper. It's probably assigned to a certain amount of values only. Okay, so if these are the number of values, let's say it adds up to 72 bytes, and if you try to receive the data that is 78 bytes per second, your backend probably won't recognize it. Okay, so you have to be really careful about that. So what's the second step? You say what data, what kind of data I'm going to receive from the rocket, what kind of data I'm going to receive from the CAN. You do this. These are the two steps. I hope you have already noted it, so I'm going to just cancel it. It's really short. Just keep it short. Keep it as short as you can. I'm going to share you the notes anyways. The third step. What's the third step is basically you open Figma. I know it's very cliche and I know it's going to be a little sad. Even Figma or even a normal, what I should say, a pen paper would do it. Take a pen, take a paper. This is the paper sheet, and Figma is more basically a software like, so it's more really helpful for you guys. And try to come up with different scenarios. Okay, so I had altitude 1, I had altitude 2, I had temperature, and I had gyro XYZ values, and I had let's say latitude, longitude of the rocket. I had these values. What I'm going to do with these values? Now the second part is basically you try to design the overview of your front end, how the front end is going to look like. And what I mean by that, let's say you'll try to say that I'm going to display the values altitude 1 and 2 in the form of a graph, a single graph with two different values. This will be of altitude 1, this will be of altitude 2. So you'll try to create a graph at the side of the page. Then you say, okay, the altitude 1 is done, altitude 2 is done. Next comes the temperature. How I'm going to show the temperature? I'm going to create another graph of temperature which will show the value of temperature lively. So this is temperature done. Then you say you have gyro values. Okay, now my rocket is asking for gyro values. What I'm going to do about that? I'm going to create a Three.js component. This is the front-end framework of basically JavaScript. I'm going to create a Three.js component of a rocket, basically 3D rocket. And as it will receive the values in form of X, Y, Z, means the roll, the pitch, and the yaw. As soon as it receives the value in roll pitch yaw, it's going to act like it. So basically, it's receiving the roll pitch yaw in a certain way. So you'll see the rocket, the 3D form of rocket trying to rotate here and there. And it will look so realistic, you will realize that even if you're getting the values in just string and you're able to, just understand the current orientation of the rocket. Let's say the rocket is coming down, so you'll see that this above, basically the nose cone will be down here. The orientation is going to change just with these three values. And how cool is that? So you design your GCS in a way that you say these are the three things. Now what's next? You say we have latitude and longitude. So you insert a map here and you say that, okay, with the value of latitude and longitude, I'm going to show the live location of my rocket, where it is. How even in just this design, it looks so cool. It looks like understandable. It looks clean that we have altitude, we have two values of altitude, we have a temperature, we have orientation, we have latitude and longitude. So That's really, that's really great. And after that, there are certain things that you have to include for yourselves, that the raw telemetry CSV that you just decoded. So basically you have to forward this as well. After every value, after all of these values, you have to create a value for, like, it will look like a blank telemetry page, or you'll say like something like, it will look something like CMD, and it will just list out the values you decoded. So for example, you decoded altitude is equal to 4, so it will say 4 comma 4 comma 23 comma temperature and etc, zero values and stuff. So it's going to say just raw telemetry, and after raw telemetry you are going to update your dashboard in this way. So this is the third step. So all you have to do is basically design into a Figma, or take a pen and paper and try to design what kind of layout your GCS will follow. And okay, great, understood. I hope you just understood this part. Now, what's next? Uh, Let me tell you, should we discuss the AI thing right now or in the end of the session? What is Figma? Basically, it's a tool that front-end developers use to create a layout for, how your web page is going to look like. Okay, let's vote. I will try to look out for votes. How many times? ESIoT, what's ESIoT? CSIoT, yeah, it is related to zero values. Right now, now. Okay. Should we discuss how we use AI? Okay. So the people are really, okay. Okay. Yep. Who cares about the fundamental anyways, right? But okay, you should at least know the similar terms, and after that, you are going probably going to use AI, so don't worry about that. What I feel is basically you should just understand the few more things as well, so you won't get yourself confused. Probably the next time you are trying to build, even prompt AI. Actually, please go with the fundamentals first, with important definitions. Great, Nihar. So that's what we have to do, right? Okay. So the mission briefing, what was it? Basically, core survival skill. First, we have to create a responsive layout. And what do I mean by that? Responsive layout is something like 1920 x 1080. You've probably heard about this ratio, 16 is to 9 ratio. So you are going to design everything in Figma in just this ratio. Don't worry, even if you don't know Figma, you know web development. Don't worry, even if you don't know that. You just say this to your AI that try to build something under this, this frame. Just whatever you build under this frame. So a little bit of information is really important at some point of time, since you'll say that even the AI, this is your AI model. You tell it to build something, and it's going to build something that looks around 65% of it, and even maybe in most of the cases 90% of it. It's just look the same. It performs the same, but there are some backend functionalities that it cannot perform, since it did not understood what were you really trying to say. So that's the role of your AI. Basically, it did not really understood what were you trying to say. But if you have a little bit of more information about how the front end logic works, about how the back end logic works, at least you'll be able to describe the AI so that it can build 90% of, even 90 to 100% of the whole software by itself. Even if it doesn't, let's say it come out with bugs and it tries to build 85% accurate of the product that you were trying to ask it for. So you have certain kind of problems in the those in the files or in the code files. So if you know the logic, if you know the programming language, and if you try to understand what just it wrote, so probably wasting 2,000 rupees, or mainly $20 or some kind of AI token. So you are just going to save some of it, okay, for the important debugging. If you can do even 20% of debugging, if you can do by yourself, then you're going to just save off your $20. That's the main goal, right? So you don't want to waste it up. So you can just go and eat something outside. Yeah. So that's right. So you try to, okay, you have a doubt if a GCS displays every available telemetry parameter in real time, does it improve situational awareness or increase the risk of critical information being overlooked? Critical information. Look, it treats every value as a critical information, and it depends on how you code it. How you design your backend, it's going to probably treat every kind of information as a critical information, and it will decode every single values that you are trying to look for as soon as you received it on your Zigbee. Okay. So yeah, I will just, tell you about the AI stuff. Don't worry. So just understand this. You will give out a layout. You will say that build me anything, but keep it in this frame. 50 hertz charting. So basically, don't worry about this. Just forget this term. Basically, you have charts.js. So you have different libraries in the front end. For example, in the chart.js, we use to make charts in the front end in the JavaScript. We use this library known as chart.js. We use this library, and to build the 3D orientation of a rocket, we try to come up with Three.js components. Three.js. Okay, we use, and for the maps, we use Leaflet library for the maps. That's as far as I know. So these are the primary libraries that we use. Okay. So what we can do is, in most of the cases, let's say if we don't have our backend optimized, If we don't have our backend optimized, we can optimize these values, we can optimize these libraries and frameworks up to our goal. So your GCS won't lag. It won't lag. Let's say you're probably trying to receive values, and the GCS, the backend says, I can receive values really fast. I can receive and I can store values really fast. I can update the UI really fast. I can send the values to the front end really fast. And the backend is sending the front end values really fast, and the chart just says that I am not going to receive those values really fast as you are trying to say that to me. Let's say the backend says I'm going to give you three values every second, and the chart just says I need just one value every 5 seconds. So you have to optimize these libraries in the front end as well. Okay. So just remember these libraries for now. That will help you prompt later. GPS mapping and 3D rendering. We already talked about that. Field ready design. Basically, you have to design the UI. In most of the cases, the visuals are going to be of keep it light theme, light light theme, and also keep it just single page. Don't try to design multiple pages. Like if I'm going to click on this telemetry page, I'm going to draft to a different page, and here I will see the telemetry values. No, you just design a singular 192.0.1.0.80 frame. This is going to be a whole page, and you try to design whatever you want right here, and then you code it that way. So that's only thing you need. Next thing, dashboard. See, this is how it looks like. The orientation panel, the role, the pitch, the yaw, these things, the value of the trajectory of the map. So you're going to use leaflet values and some another secondary health component. Basically, how the temperature is falling. You try to insert an emoji here. You try to insert different emoji here, and then you try to come up with different component of the CSS. You use CSS language to design these kind of things. So as soon as your CSS receives value 20, it will set the voltage, the animation of the voltage to 20, and it will set right here the value is 20. Similarly with the temperature, similarly with the altitudes, and similarly with the different values. So you see, we use Chart.js here. We use charge here. We use leaflet here for the maps. We use the Three.js components for this rocket orientation. And look how great it looks. Even with the simplest design, look how it really outperforms everything. Like the simplest designs is the best. The simplest is the really the best. Okay, now you have HTML. Okay, what do you need to know? You need to know the HTML CSS foundation, and you need to know the basic how you code, how you basically code the CSS. You need to know these kind of terms, basically understanding with how these things works. So even after getting the response from your AI, you can optimize it. Even if it has a little problem, let's say 99% of everything you needed is done, and just 1% you did not got right, and you try to prompt the AI, and just by doing that, the AI just trying to just understand whatever you said, how to fix this 1%, and it disturbed your 90%, 99%. So now you are back at 65%. Now your software only works 65%. What does it even mean? It's not going to do anything. Okay. So you should at least have familiarity with these things. Just understand the CSS, HTML. It's probably going to take you 2 hours to watch these lectures. Then comes the Chart.js optimization. You have to survive the 50 hertz. Let's say even if you receive 50 values per second, you're going to decode it and update your Chart.js in a way that it looks like this, not something like that. Okay, so how you'll optimize it? So then you need to understand the knowledge of what a chart is, how you create a chart, how you create a component, how you update it values, how you receive the values, and where you optimize the latency, right? Updates, batch, and decimated. Basically, the main thread protected and the smooth rendering. The common technique is basically this is your main thread running, carrying out your processes of data updation in the chart. This is your main thread. This basically that say this, it's trying to take your data to this library, the Chart.js or Chart.js of you have while this Chart.js you have different libraries. Basically, you have different charts that you're trying to show, one of altitude, one of temperature, one of pressure. And basically what happens here is you have to keep your main thread in a way. So even if it receives 50 values at every second, it's not going to break the values of altitude, pressure, and temperature. So they should keep updating really smoothly like this, not something like zigzag, zigzag, zigzag. Hope you understood this. What happens to the trajectory if the GPS updates are delayed by 2 seconds? It just updates it. Let's say you receive the value. The trajectory was supposed to be here to here. Okay. You receive the value here at the rocket really moves up really fast. So it's like probably in a few seconds, it's going to be from point A to point B. So you won't even see the readings at these points. It's going to go up that fast. And you're trying to say that I have to decode the value every second. You have to decode the values every second. So as soon as you receive the values, probably the rocket was here, and it's going to say that now the rocket is here. So what happens simply is basically you receive latitude, you receive longitude. That's it. You update the value. Then again you receive latitude, again you receive longitude, and you update the value. Even if there is a delay, you will just recognize it later in the spreadsheet, basically in the Excel sheet. Since you are trying to store the data at the same time, as soon as you are updating these elements, you are trying to store the data as well. So after the data analysis, you will be able to understand that I did not receive the latitude and longitude between these values, but whenever I received, I updated the map position of the rocket. Understood, people? I hope you understood this. Don't worry, even after this session, I'm on LinkedIn, so you can message me for your doubts as well. Last time it happened the same. Okay, so people were trying to message me on LinkedIn, and you can ask anybody who was in the session. I cleared the doubt, and I was able to respond really fastly, and they were trying to ignore me. That's what happens. So please finish the topic and flow, and then check the doubts. Difficult to stay on the track because the topic is totally new logically to us first timers, and there are 32 slides. Don't worry about the slides. You can cover up the slides later. Just trying to understand what I'm trying to teach you right now. The slides are basically, let's say, I try to explain to you these topics between before the slide even came, right? Just understand what I'm trying to say. And probably I can end up, if I have to just close up the slides, I can just explain you this is that and this and that and this and that, like an old teacher. And I'm going to explain you everything. And you'll say, okay, 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 okay. You don't care. And your money wasted. You did not understand anything. Your time wasted as well. You don't want to do that. One more question. What single improvement would provide the biggest increase in the mission success probability? Single improvement that I have to look for is basically whatever thing that your system is lagging. If it's lagging in the backend and you try to improve the data credibility, you try to improve the data receiving reliability. So you have to improve your hardware. So you improve your Zigbee. You have to look out for the improvements constantly. Even for teaching part, there isn't a proper flow of ideas. It's getting confusing. Proper flow of ideas. Okay. What happens? Let's say after this session, I'm going to conclude it. Okay. Everything that I've taught up until now, if you did not understand a certain step, you can just message me on LinkedIn. Okay, so you wasted my time. I did not understand this. Please explain to me, and I'm just going to text you back. Don't worry. I think you should start developing a GC directly. We should understand a lot more by seeing the actual development and the working process. No, that's not going to happen. If I just started building a GCS right here in this session, like I was doing tomorrow, most of the people did not even understood that the basics of the programming. I have to, let's say what happens is, if I try to just try to code the GCS, I'll probably try to code the Python backend, or try to code the HTML CSS right away, even just the basics, so you can understand what's happening. I'll try to write the events, asynchronous events in the JavaScript as well. But if someone is experienced in Python, it's not like everybody is experienced in Python. If someone knows HTML, CSS, and JS, they probably don't know the library that I'm talking about. And even if they do know JS, and even if they try to understand the code, they will. But it's not certain for everybody. Like we have 750 plus members in this class. So let's say if I try to explain something like programming language, I don't even know the fundamentals of everybody is clear in the Python or in the HTML sections as well. So how I can assume that everybody knows enough? So it's like just wasting your money. But if I tell you the right path way for you to build a GCS, what are the factors that affects your GCS? Even what are the factors that try to affect your GCS? Even if you're trying to use AI and stuff, where are the things that you can improve your GCS on? Where are the things that you should understand? The bare minimum functionalities of your GCS. If I teach you these things, then even after the session is ended, you can just visit back here. And don't worry about it. If you're trying to say that I don't have the code, how will I learn? He did not teach me anything. Don't worry about the code. I'm going to share my GitHub repo as well. I've built more than 5 GCS telemetry software. Some included AI, some does not really run or ML applications. But basically, they have ML frameworks attached to them. So some of them are just the normal GCS, the telemetry software that you're trying to build. So if you're trying to take reference of the code, don't worry about it. I'm going to provide you the code. I'm just trying to say that understand the fundamentals. These are really important. Even from I'm not just trying to teach you the basics of what is the GCS, how you build it. I'm trying to teach you that even if you encounter errors after this class, how you're going to fix it. That's my motive, right? Since I'm an engineer as well, since I've built GCS as well, I know that I cannot build it by just scratch, and I cannot understand somebody building it by just scratch. It will. I can feel that. I will feel that. Okay, I'm learning something, but I won't be really learning anything since I'm just trying to copy paste the code, and that's bad. Can you please go to next, please? Thank you, sir. The structural part of the cancer on the Rocketry. Structural part that I cannot really explain. My expertise lies in the software. If the GPS and your telemetry data disagree with each other, how should the GCS determine which source represents reality? What? Can you, Shankarjeet, can you just rewrite a question in something in a way that I can understand? Yeah. So let's just continue. I already talked about this library, the leaflet.gps tracking, the offline map. What happens we have 1 hour left, so don't worry about the session. Leaflet.js, the GPS tracking, the offline map. Out on the launch pad, you have 0 bars of Wi-Fi. Cloud CDNs will fail you. So if you rely on something like CDN, those of you don't know, basically your chat GPT or your YouTube, it uses CDN. What's the role of CDN? It uses internet, it uses the connectivity and speed, and on top of VPS. So it reroutes. So even let's say the YouTube servers are at Australia, so you'll be able to see YouTube videos from YouTube really at fast speed and great quality even in India. See, so that's the goal of CDN. Okay, so it just uses internet and stuff, and it can load videos from really far away to your desktop, at a really great speed and great quality. So basically, what happens is So well, in building GCs, we have to realize that we are not going to have necessary components like leaflet.js. Even if I said that we are going to use this, most of the cases, the area where the rocket is going to launch, you won't find any network services. You can simulate the sensor readings as well, creating the Python server and then creating a script to catch the values from that server. So you can use the Python library as a backend and as a front end, basically front end interface for the back. To those of you are really worrying about, I won't get the code, how I will see it. Uh, I'm going to share you my GitHub, and you're going to paste that GitHub on the AI, and you'll try to say, let's say you understand Python, so the backend is in Python. You'll try to say, okay, just understand, just tell me. So let's say you remember XYZ topics and methods that I taught just that I just taught you in this session. You're going to remember that, right? So I'm going to prompt AI by saying that here is the code, here is the Python code. Just tell me how these things that he taught, how it works, and how I can code it on my own. Since if I just taught you right now everything that I'm, most of you people don't have really background of computer science. Even if you do, even if you don't, and even if you know the Python, it's not like I can assume everybody to know Python. So for somebody who paid the same as you, who's trying, who's from different background, who doesn't really know programming, if he's trying to understand something, it will be really hard for him if I just go to the coding and concepts, right? Okay, so yeah, I was talking about the leaflet GPS tracking the offline map. What we have to do is we won't have any internet connection. This is the library that we use for our maps. This is the JavaScript library, and we use it in the GUI. And what happens is if we pass our two values, latitude and longitude, it's going to show us the trajectory. It's going to show us the value of where it's the rocket in the map. And you're getting constantly different values of latitude and longitude as the rocket is going up and down. So you're receiving value here, and you updated the map, you receive the value here, you updated the map, you receive the value here, and this is your trajectory. So you can show all of this inside your GUI using leaflet.js. What happens is it requires the internet to work. So we don't have internet connection. So we have to find another way. Mobile Atlas Creator pre-launch. Don't worry about it. Okay. The local file directory. That's what we are going to do. We are going to store this map, the map of this coordinates. Let's say this is the coordinate system. This is the latitude one. This is the longitude. This is another latitude, longitude. This is another latitude, longitude, lat long, and this is another latitude, longitude. We are going to take up these four coordinates and we are going to install every pixel, every images like this, the patches of images in our local directory. We'll say that these are the four coordinates. So we already know where we are going to launch our rocket. And the launch site is pretty much clear even before several months of the event. So you know where the launch is going to happen. So you just go and take up four coordinates and you try to store the image patches of from Google Map or whatever libraries that you may find, and you just update those patches in the local file. You install them, and then you use a library, a framework from Leaflet to Canvas to convert it to Canvas. So basically, you have these images, and it will say, okay, this is the latitude and longitude of your rocket. It'll say that load this images from the local directory since it's already installed. So you are just going to load these images here. So you'll see that the rocket went here or not. How it's even possible? What? Ashwath, can you? Okay. So now about the orientation. You have Euler angles, you have quaternions. What happens is you give these values, roll, pitch, y, the roll x, y, z values, and it somehow converts it into a Three.js component. So what happens is just by getting three simple values, x, y, z, that the rocket is feeling through its sensor, and it's saying that this is my current orientation. I'm going up and I'm going down and I'm going left and I'm going right. So how the rocket is, how the rocket can see itself. So it sends you three values, the roll, pitch, yaw. And basically, just by using three values, you design a system. Basically, using the quaternions, there is a formula. And basically, this is the critical implementation, one-liner implementation. Okay, so basically, you give telemetry.role. Basically, this is the telemetry object. And you telemetry class basically, and this is the object of that class. So you try to give it the telemetry role, you give it the telemetry dot pitch, you give it these values, and you create a rocket mesh dot rotation dot set, and you set these values. And after you set these values in the rotation part, you are going to program a way, you are going to ask an algorithm, and in terms of quaternions, that basically it converts these three values and it will pass down to your Three.js component. So this is your 3D rocket. It's going to stay still, assuming that your values are 0, 0, 0 by default. But as soon as it receives some kind of value in terms of X, Y, Z, it's going to update it. So it's going to be diagonal. It says, let's say it, it recognizes, it says that the pitch or the yaw, it's basically, let's say the user updated yaw. So it's going to be like tilt like that. Okay. So that is what happens. So this is the next thing you do. This is the front end part basically. I think it's getting confusing for most of you guys. Is it getting confusing? Just comment down. Not 4D, it's 3D. A little bit, kind of confusing. Yep, it's hella confusing. It was for me, and it took me really like it took me 1 month at least, and I used to sit around 4 to 5 hours every day trying to understand what I'm trying to build. No, it's we have to program it while building the GCS. It's very confusing, right? I know it is confusing. So the problem is you are trying to get a load of information in just a 2 hour session. Uh, what I'll say is don't try to remember what I taught you. Just try to understand what I'm teaching you right now. I'm teaching you how these things work. Just say, okay, they work. I'm saying this is how they work. You'll say this is okay. I got it. And the important part is going to come after the end of the session where I'll conclude everything. There I will discuss about how you can use the powers of AI. So at that point you have to really listen everything really carefully. So that's the part where you're going to use whatever you understood. Let's say you did not understand anything, you did not understood how the map is created, so you're going to come back to this page, you're going to say that okay, role page, yeah, and it created something like this. So okay, if I'm getting role page and yeah, I have to ask my AI to build something like this, and it will probably give you the code and you will try it. It might not work, it might work. If it might work, you're going to understand it. If it didn't work, then what you're going to do is you're going to come to my GitHub repo and you will find there are 5 more GCS. You open up any kind of GCS and you'll try to look for telemetry or maybe orientation, and you'll see that okay, this is working. So then you clone the repo and then you understand the code, and then you understand finally, now I know how it works. See, as simple as that. So don't worry, it's this lecture is not going to be a waste for you. It is really useful. And even as a robotics student, it is really useful. But it depends. It depends. If you are going to, let's say there are robotic students who are focused on hardware and stuff. There are robotic students who are trying to focus on the software part of the robotics. So you cannot, even the small robots you can make on your own. But you, again, there is a team that works on the robotics, right? So if you're trying to go for the software part, you can just clone my repo. You can ask AI to, just adjust it according to your goals. LinkedIn or GitHub, let me just share you my LinkedIn and GitHub right here. Now, don't just go around messing up with different projects. I know I try to build up, and most of the time it's for the competitions. Most of the time it's trying to help my friends. So just ignore that. But yeah, anything, if you encounter any word like GCS, you have to just study that. GitHub.com/. This is my GitHub. And this is my LinkedIn. LinkedIn.com. This is my LinkedIn. Because Euler angle can give the wrong orientation prediction when the rocket flips to slightly exceeds 90 degree, right? Yeah, the Euler angle can give you wrong prediction, but in our case, we are not here to fix the predictions. In our case, we are just going to receive 3 values and we are going to update it on the 3D map, on the 3D component. That's it. That's all we are going to do, right? Let's move ahead. WebSocket connection, and this is really interesting. One of the most important parts, and even in the back end and the front end, you should now focus. Okay, just forget everything that I taught you up until now, and just try to focus here. Your the focus at this point is really necessary. This is important. The WebSocket connection is important, and I'll try to keep it as simple as that. Till now, from the start of the small flowchart, can you sum up the topics, sir? Topics. Okay, in the end of the session. How about in the end of the session? Chemistry student. Let's say you are a chemistry student. Let's say you have CO2 sensor. Let's say you have CO sensor, you have NO3 sensor. If you are a chemistry student and if you're trying to build a project that you have a microcontroller and that is attached inside a breadboard, and the breadboard consists of these 3 sensors and different things like that, and then you have a Zigbee as well. So basically, what happens is this is your whole system. You are just going to keep this away in, let's say, back of your room. This is the room there, and it's probably it's going to be the distance probably can have on the basis of the distance that can hold by the Zigbee. Let's say I'm going to take this 3 kilometers. Sitting away 3 kilometers from a different room, you can just sit in your own room, open up your GCS, and try to code for CO2, CONO3. It's just receiving these gas values, and try to create a component and try to you can what you can just do is try to create an emoji you'll say that as soon as you receive these values that are, that fits under the survival condition of humans, you are just going to make a smiley face or you are just going to make a sad face. So let's say by some kind of activity in your chemical lab that was 3 kilometers, you were sitting 3 kilometers far away, and just by opening up your laptop, if you see a smile, the sad face, you can understand, okay, there is something wrong with CO2, CO or NO3 values. That means my experiment did not go right as I planned it for, and that means I have to, I have to probably get back and fix some things right there. How about this? Did you got this idea? Does it look great? I think it's great. Even for a chemistry student, this looks great, right? Okay. So it is going to be useful to you. Don't worry about it. And don't try to steal this project. Okay, it looks fine. So probably this is the next thing I'm going to build. About the project, can you confirm, Radhya, about the project or the topic? Topic, yeah. The WebSocket. Let's understand. Forget everything that I've taught you up until now. Don't worry about it. Forget it. I'm going to, just explain you even after the session. Just stick up to this, the WebSocket connection. What it is. What it is. Don't worry about it. It's probably going to give you some kind of marks, and it's really good. I think I'm going to steal it. Compile notes. Yes, there are other compile notes. That's how, as simple as I can decode this idea of WebSocket is when you establish a connection between your front end. Don't just forget about this. Let's say uh, there are two types of friend, right? In my cases, I'm just going to say that there are two types of friend. One is you probably chatting to them like 24x7 in most of the cases. If you are friendly enough, you're going to chat them, you're going to text them, you're going to call them 24 by 7. And they are really friendly. They are good friends, or maybe bad ones. I don't really know about that. So they are just friends. Okay. They are friends of one type, type A, and they are friends of type B. What happens with them is you try to text them. Okay. You try to text them, hey, you try to text them hi. You try to text them happy birthday. You try to text them how you're doing and good evening, good night, and something like that. So you just text them and they see, okay, he's sending me hi. So they send hi. And then after some time, you talk to them, you say, hey, good morning. They'll say morning. That's it. So, and the second variety is the type is you're just texting them 24x7 saying that, you're probably talking bad about your teachers. You're probably talking even about me that, okay, there was some, this guy Gaurav and he was giving up bad examples about the stuff as well. And he's probably so confusing at teaching, doesn't really know even what he's teaching right now. So you talk about this to a friend, the friend A 24x7. The friend A is WebSocket. As soon as it receives your message, it replies to you. It's like he's already available for you 24x7. What I mean 24x7 is already available always as soon as you open a port. You open port 3000 in your laptop and you says, this is the WebSocket connection. The WebSocket connection connects your backend to the front end like nearly 24x7. As long as the port is open, it's going to connect up 24x7. But the friend of type B, it's basically what we face usually, HTTPS. Like you go ahead and search for you go ahead to the Google and you try to search for something. Okay, so my battery is going up. My battery is going up down. 20 days. It's probably going to be dead in a few minutes. So let me just charge it up. I would request the host at the same time to just unmute unmute the different device.
Yes,
Okay,
sure.
I'm
I'm
going
doing
to.
it. Just a second.
Yeah, please.
So I have sent you a request. Please unmute yourself.
And
So your voice is echoing.
Is it fixed now?
Yes, sir. It's fixed.
Okay. Don't worry, Soumyadeep. I'm going to accept your request just right after the session, and I'm probably going to uh, accept it before you can see it. So yeah, I really stay active on LinkedIn. So I have my teammates, I have my researchers, and I have my people from different colleges. So they are doing research in different ML and AI fields. So I'm probably on the lookout of new research paper as soon as I get one. Okay, so did anybody understood this idea? What I was trying to say here? If my screen is visible, yeah. So did anybody understood this idea? There is a friend A, and then there is a friend B. Friend A, it's like 24x7. It's available for you. As soon as you text them, he's going to text you back, or she's going to text you back. And then there is a different friend of type B.
you text him, and he's just going to text you one time after probably a few seconds, and then that's it. That's all he can do. So here what happens is WebSocket is basically like a friend A. He is available for you 24/7. And HTTP's request, the other friend B is basically HTTPS request. What happens is you go to your front end, basically front end of google.com. Okay, go to google.com, search for something like black monkeys. What happens is it's going to the front end, the browser or the front end is going to send a request to the Google servers just a single time. Okay, just a single time it's going to send a request that, hey, somebody at this IP try to look up for black monkeys. Do you have the pictures of the black monkeys? It says no, not just a picture. I have everything, all images, videos, and everything about them. So it's going to load everything that it knows about the black monkeys, and it's going to rank them. Just a one-time process, right? You search for something. It's not like Google is always trying to text you, or it's not like Google is trying to say that search up for something. No, that not happens. Okay, so you go to Google. So that's a one-time request. You so this is your friend at Instagram follower that he's trying to at Instagram, and he's trying to ignore you. This is the follow request button. So you just click this follow button at one time, and it's going to convert to the requested button. Okay, it's going to say that requested. That's it. What after that? It's just an HTTP request. So it reached the servers at Instagram, and after that, it reached them back to your friend who's probably at the notification, who can see that, okay, there is some dude who sent me request, follow request, should I receive it or not? And he's probably going to ignore it most of the cases, right? So this is basically HTTP. So to make the connections fast, like a WhatsApp message, to make the connection fast, like let's see, whenever you can text your friend anytime you want. So that's a WebSocket connection. The connection between the client and the browser, the client and the server, or the front end or the back end is already open. So they can communicate anytime they want. They don't have to just wait for anyone to just give out some kind of request to perform an action. They'll just try to listen to each other and try to communicate anytime as long as the port is open. So same as these chats on Zoom, it uses WebSockets. Great. WebSockets. WebSockets is what we are going to use in our GCS applications as well. To communicate the data that we receive from the backend and to transfer the data to the front end, we use this WebSocket. And in the backend, let's say in the Python, we use the WebSocket library that is known as Flask. Flask is the micro framework, micro web framework. Okay, micro web framework. Then you have Socket.io. Flask created, this library, a framework known as Socket.io. So you can use Flask Socket.io. You can just install it. We discussed it in the previous session as well. You can install this library, and next thing you know, you can just use it. Okay, and this is the part of the backend. Now you need something in the front end that can understand Socket.io connections as well. So we use JavaScript. We use Socket.io. Socket input output. That is the library provided by the JavaScript. So we use that. Understood? Shall we proceed? I can see there are a very less number of people left in the session, but don't worry. So what we do is there are 4 simple steps. You can just read it on your own. I know you are capable enough to understand the basic English. And then it's DOM performance, protecting the main thread. Oh my God, I think it's going to be a little different or difficult. So please explain the last part of it. Priyanshi, see, let's say you, what I meant by WebSocket is basically, there is a friend. Okay, there is your friend. Let's take, I need a name from the chats. Let's say Dhanvi. Okay, Dhanvi, she is your friend. What happens is Dhanvi is going to come to you and say that I'm your best friend. So I'll be always available whenever you're trying to, reach out to me. So Priyanshi will feel like, great, she's my friend. So anytime I want to text her, anytime I want to ask her a doubt, anytime I want to, tell her about something, anytime I want to share something, anytime I want to discuss anything, I have Dhanvi by my side, and she's going to come just whenever I text him, whenever I text her, she's going to reply to me. So she's Dhanvi. Okay, so she is basically not going to just change up the name, but what I meant is basically, so that kind of a friend is basically how WebSocket works. WebSocket is basically, you are a client. Let's say you are a client and you have your friend as a server. In normal cases like HTTP, we send a request to the Google server and we get the output. It's not like every time we are receiving something from the server. But in the case of WebSocket, you can send anything you want. You can just send anything you want and you'll get the reply instantly. Even the server can communicate to you anytime it wants, anytime, as long as the port is open. So basically this is the, as long as basically you have both opened each other chats, basically as long as you're all on the same port. So the port is open. So as long as it's open, you can just communicate from the backend to the front end or the front end to the backend really fast, like even faster than 1 hertz. See, that's the role of WebSocket. And these are the 4 topics in the important WebSockets. I'm going to send you the notes. DOM performance, protecting the main thread. Now I want to know how many of you are familiar with DOM. How many of you are familiar with JavaScript? No, yes, no, no. Document object model, great. Amit knows. Yes, no. So there are more no's. What should I do? To the people who don't know this, to the people who know this, you know how DOM works. You know how the performance we have to optimize it. How we have threads basically. Okay, we have different threads like this, each carrying out different processes. To the people who don't know that, let me just justify it for you in simple terms. What I mean by that is, you have 3 things. Let's say as soon as you receive the data in the backend, what you're going to do is you're going to save the data. You're going to send the data to the UI, and you are going to decode the data while doing all of that, and you're going to do everything in just a single second. So in your JavaScript, you have multiple components in the UI. Let's say you have Chart.js, you have your leaf, you have your orientation, you have 3 values in the orientation, you have 2 values in the maps, you have different values in the telemetry as well. So you are trying to update multiple values at a time. So this is basically a lot of work for the front end to do as well. The front end is supposed to update like 72 values at a time at every second. So how it's going to be performing that? Well, we have a DOM performance, basically the protecting the main thread that decodes the data and that updates the value at everything. Okay, so the main thread is basically reserved entirely for UI rendering, how your data is going to load, how the Chart.js is going to load, how your bar graphs are going to load, how the rocket is going to change its value. So you have one thread. When I say the thread, basically let's say some you can understand people who are trying to do different work. Okay, so there is people A, this is guy A, he's trying to update the CAN-set value at this point, and there's guy B, he's trying to update the different value of a CAN-set, and C is trying to update different value. These are all different people. And then there is one people, the main guy M, it's trying to update the UI thread of all the components. Okay, so you have this main thread reserved, and then you have, let's just to simplify all this, you have a different thread to update all of the values. That means, and if I have to summarize this page in a way, I will say that you have different things in the front end to update, and you use basically threads. You use threads means, in terms of understanding, you use multiple people's. Instead of asking just one guy, you ask multiple guy, a team of people to update your values. So it's not like if one is forgetting something and it's at the same time, if you ask one guy, it might forget some values to update. But if you ask multiple guys and each guy is just the work of every people is just update a single value, so they won't be able to confuse themselves. Okay, so that is the DOM performance. Field ready design checklist. Access locality, you have to access the leaflet map, you have to access the coordinate, you have to pre-save the coordinates. So you, even if you don't get internet, your leaflet map still loads and you can still see your maps data. Okay, so access locality first, then power visibility. You should have a battery backup of your laptop. It's not like your laptop is going to shut up midway. The semantic phase is color. The color coding is strictly functional. Green, pan, land. Basically you have to use green for positive things like the landed. It's on the launch pad and it's completely working. You have to use yellow on something that is like sign of a warning that can have a problem, or basically in the mid processes like the rocket is ascent, rocket is on ascent, rocket is on descent. And on the cases of emergency, not the descent, on the cases of emergency, on the critical things, let's say some sensors stopped functioning, on that case you are going to use red. Okay, red color. So you have to be aware about the colors, and the overall background you have to take as white. So even in the daylight you will be able to see the GCS properly functioning. Audio redundancy, programmed audio alerts for critical events. This is probably you don't need that. Okay, you don't need it, so just skip that. Hands-on exercise. First, ignition. Build a minimum robust dashboard connected to a simulated telemetry system. Okay, this is I was going to teach you, but let's say just what we are going to do is you will try to build it after the session. And okay, you are trying to access my GitHub repo, github.com/root hats. And in your case, I'm going to recommend, I have a repo of our team, Trishul. Just use that. Okay, just go on to the software V1 page and you will see GUI, you will see script. Since the backend is written in the JavaScript, so you will see script, that's your backend. that handles the code, that handles the data, and then this is your GUI that updates the UI. So you are just going to understand this code base. If you are already familiar with Python, if you're already familiar with JavaScript, you are not going to have any problem with that. And if you're not already familiar, even if I'm just going to write you a code down here explaining you things, you won't probably understand since you don't even know the language. So that's the reason I'm not trying to teach code here, since it really wastes time of some people's. Chart.js, line chart. Okay, so this is basically your task. Try to do that. Even if you're not able to do that by yourself, just try to use AI. If I have to use one, I'll use anti-gravity probably for this task. Then we have summary and estimations. Okay, data logging. Okay, so you have multiple layouts. You have to design multiple layouts. That map should be here and graph should be here and stuff. You have to choose up your charts, what kind of charts you are going to choose for the mission. You have to choose a 3D model. You have to design a 3D model before, and you have to create a lifeline, basically anything about the WebSockets. And then this is your map. This is nothing, so I'm going to just write empty. Anything that you feel fine. What gets logged and gets proven. This is raw data stream. Okay, if you look closely, just going to use different. If you look closely, this is altitude. This is latitude, then again this is altitude, latitude, longitude, and you have voltage equals this and that. So this is the raw data stream. That is basically what is decoded. It is decoded already. And then you have data integration validation. So basically you verify that if the values are right. The 3 phases of decoding that I discussed. Decoding, what was the first phase, and then was second phase, and then was third phase. Look out for headers, decode the values, and convert the values into float. These are the 3 phases of decoding you should remember. So basically the header part, the first phase is either you can do it with header or either you can do it with checksum. Okay, or either you can just choose both of them or any of them. I would just recommend not skipping the header part. The structural parsing, and then you pass it after you have the data, you pass altitude equals 23, and that's what you get. You get these values, altitude 1523, latitude and this and that. See, and after you just pass this value, this is the end result what you get. This is basically the trajectory, or this is basically the value of latitude, longitude, and stuff like that. So even you can create a 3D map, or you can create a 3D chart by yourself. This will be considered a part of your innovation. Format, buffer, compress, validate, deconstruct. These are the steps. You can read it by yourself. You'll be understanding. I have explained these things already. Incident report. This is basically the analysis you do after the flight. You have to create an incident report. Let's say, no, this is not going to happen. Let's just forget about this. Let's say you got an error log that says altitude not received. Okay, at point from 2 seconds after the launch to 4 seconds. In between these seconds, the altitude value did not received. So that is altitude. Okay, so that's your error log. So this is the incident report after you have collected your memory card, or from the PCB, or from the rocket, or after you have collected, basically after the rocket is finally landed and you have your CSV file that you saved, the values that were passing throughout the mission. You have already saved it inside an Excel format, so you can just do an incident report on that. Yeah, this is the standard scheme. You are going to decode your values like in this way. You'll say the first value of going to be of time, second will be of altitude, latitude will be third value, longitude will be fourth value, and this is how your Excel sheet is going to look like. See, this is your Excel sheet, how it's going to look like after the mission. Direct to disk login cause fatal bottlenecks during high frequency capture. So if basically what this, let me summarize this. If you receive a data packet of 72 bytes and you have to append that packet on the buffer, it's like a memory, like let's say 20 MB memory, or let's say I'm going to just keep it to 50 MB. This is a buffer that stores your value. So it stores your value to update the front end smoothly. Let's say this is your bucket. Just simplify this. In the simple terms, if I have to say this, I will say this is your bucket, and this is the tap water. So you are getting tap water from here, and if there is no bucket, you'll say that you are getting, if you have to just count the droplets in this tap water, and you just turn down this tap water for let's say 5 seconds, it's just going to flow out so fast you won't be able to count the droplets. So if you have to update the droplets, if you have to count the droplets, you need to be really slow. So you say that for 5 seconds, let's say the volume of water that it's going to become around, let's say 3 liters at max. Okay, so you take the bucket of the volume of 5 liters and you put it up here, and you just create a hole in the end. It's small enough to just give out little droplets. And even if it's going to flow really fast, your bucket will hold it for 5 seconds, and after that it will hold it and it will just only give out droplets in a way that you can count. So this is basically what your buffer is. You store the data that is coming really fast in your buffer. You store when you receive a packet, that is really fast, you're going to store it in a buffer, and that should be the size of more than for how many seconds. Let's say the telemetry is going to receive from 5 minutes, and every second you are going to receive 72 bytes. So 72 into 60 into 5. So basically how this sounds, this is number of, let's say, x bytes. So you are going to create a buffer of 2x bytes. Okay, so 2x bytes. So basically this will, let's take it up example. Let's say it's going to be a 50 MB. So you'll create a 50 MB. So that will help you. All the values are going to be stored in this 50 MB bucket, and slowly it will update the elements in the UI enough so you can see. You won't see this like values. You will see your graph updating like this. Okay, so that's the use of a buffer. I hope you got it. Let me just see the chat section. Just look for this. Anything in the GCS would help you, but look for Trishul GCS. I'm looking for more doubts. Please, if anyone did not understood anything, you can just comment me. There are literally so many topics that I have to discuss today, but don't worry about it. I'm just going to discuss a few more of them that are just important. Like I already discussed the header for footer format, and I already discussed this checksum, and I've already discussed the offline replay tools. Basically, you don't have to worry about this for right now. You will just understand it later, and you just have to read the PDF one more time. The review room exercise. Okay, so this is your exercise. If you know pandas and matplotlib, these are the library. Pandas basically, even if you don't know, pandas is basically used to handle data frames, something like CSV values, something like tabular values. So it's used to handle the data frames, and matplotlib is basically convert these data frames or these values into charts. So pd.read CSV, you don't have to worry about these values at all. You only worry about these values when you have to just create a UI on Python. But we are not going to do that, since the UI that we create in Python, it's really slow and it's really buggy and it's hard to manage. Okay, so that's why we use Python as backend, and we use Node.js as frontend. The complete chain of evidence pipeline. Okay, you already know this. We receive something from USB. We parse it into understandable format, the decoding thing. Then we update the values in the graph, and then we stored. After updating all the values, we store like altitude was this, time was that, gyro value was this, and that. We store every bit of value that we got, and then after that, we just, even after the flight is over, we can reanalyze the values. Since we have the CSV file, we can just re-upload the CSV file in our GCS, and we'll say that just play the CSV file, just update the CSV values. Okay. Now comes the main part. I hope you're interested in learning this thing. No, the binary telemetry is more efficient, and you should use it. Basically, you should receive the binary telemetry, and you should convert it to human readable format while storing it. So you are receiving the value that is quick, but when you are decoding, it's a little bit hard, and it's not as hard as you can see. It's like 0.1 seconds, and you can just convert it into files. Since human does not understand binary by default, we have to take a pen and paper and try to decode it by ourselves. General Piaget CubeSat theory. Okay. Basically, this session was supposed to be enough so you can understand the basic fundamentals enough so that you can prompt the AI, or even if you want to build your own system. But right now, for this, just like for 10 minutes, I need the attention of everybody in here in the screen. And I'm going to discuss the most important topics that I know for utilizing AI. Since I know most of the people who are in this session do not really have the computer science background, and they are just probably building just so that they can save their team, or they don't have to worry about basically the software part, and you can just understand enough so you can just post that you have built a project and tag me, so I'll reply back. Now what you do is git cursor writing code that survives teamwork. Okay, suppose I'm going to discuss the AI part right now. After that, I'll discuss the git thing and the cursor thing and this and that. In starting of the session, I said you should before building a ground control station system or software, you should already be familiar with what are going to be different number of ports. Let's say rocket port and CANSAT port, and then video port. You have, let's say, your example. Take an example. You have all these ports. Then the next thing you need to do is basically you need to have the rocket. Let's say you need to know what kind of data that have. What data? Since the rocket has the data of LTD, since the rocket has the different format of data, okay, so the rocket is going to have a different format, the CANSAT is going to have different format. After having the format, you're going to design the UI, how it's going to look like. Let's say you don't know, and you don't want to design, you don't have really so much time that you are going to set up open Figma, trying to learn Figma and then trying to design. No, don't worry about it. What you're going to do is you'll say that, okay, based on this data, I need a map in my GUI, I need a map in my GCS that will update on latitude and longitude. Map updates on these values. I will have a rocket orientation, a 3D model of rocket orientation. So you don't have to build it by yourself. It's already inside my repo and the Trishul GCS. So you can just go away to this repo, and then you can understand how this thing works. And you can even open GUI.html and you will see that, okay, there is this component. You can copy it directly. Don't worry about it. It has the front end functionality as well, so it will probably work with your backend. Let's say you need, so then you discuss what kind of components you need in your GCS. Let's say you need a map to show the trajectory. You need a 3D component of the rocket. Then let's say you need charts, you need graphs, and then you need basically something, a command line CMD looking like thing that translates your package. And then you need to have a basically option for selecting the ports of the rocket and ports of the CANSAT. These are some things that you need your UI to have. Okay, you are going to ask for AI. You're just going to write a prompt that build me. You'll say build me an 19201080 frame. Okay, single pager dashboard. Okay, completely in HTML, CSS, and JavaScript. You'll say build me a dashboard for a rocket telemetry system completely on HTML and JavaScript, and HTML, CSS, and JavaScript. And it's going to be completely in a single pager. And then point wise, you are going to describe that you need a UI that consists of a map. So you say first point, I need my map. I have these rocket values and it will update on receiving the values. I have a 3D component that I stole it and stored from this website, and I want you to integrate it here. So I'm just going to paste the file of HTML, and you'll say that, okay, integrate this thing inside the GCS as well. So you are going to describe every component, and you are just going to ask for an HTML, CSS combined file, and you're going to ask separately for a JavaScript file. That's your front end. Basically, why I'm not relying on Next.js or React.js? Why? Since most of the software use it, so I should use it too. And it saves you token. It saves tokens, since you don't have to write so many things on React. If you are going to code the front end, if you write in React, in probably less tokens, you can write the code. And if you have to write the code something like HTML and CSS, it will take you more time. It will take you more lines of code. But still, this thing, it's by my experience, this thing is 100% easy to debug. That's it. It's really easy to debug, and even if you don't know how to debug, it will take you just like a single week to learn these 3 languages enough so you can debug it by yourself. Something like this is going to probably take you more than 3 weeks. So, and it's really hard to debug. Okay, so you won't be able to understand the code by AI as well. What were the steps? You know what kind of code you have, what kind of data and what format of data. You know what kind of UI are the things you need in your UI, and after that you are just going to open up an AI and you are going to explain it everything. Now in my case, what I do is, let's understand this AI game, how we do it, how we prompt the AI in a way that we get the result that we wanted to. The simplest structure that I will explain is, you open Claude, and then you'll say that you'll describe your project. Describe what you want to build, describe the project, or describe the GCS. You described it, great. Next thing you need to do is, you are going to ask for a PRD, project requirement specification document. PRD is basically project requirement specification document. It comprises of what the user wants, okay, what the user wants to build, and what are the frameworks, what are the requirements like the tools and stuff. So it writes up, the Claude will give you the PRD. Next thing you know, you are going to ask 2 things from Claude. First thing is the PRD. After describing, you want a PRD from Claude. This is the first thing. Second thing, you want your Claude to give you a prompt. or just skip it. After this, we're just going to say it. Let's say even if you don't know second thing, you're just going to describe the project and ask for PRD in such a way that it guides tool agents. Now you need agents. It guides agents like anti-gravity, and then cursor. It can guide agents like anti-gravity and cursor. Okay, so you need two agents. I'll just go with anti-gravity for right now. So you just ask for a PRD describing by your project, and then you have to ask the PRD in .md format, like you have the .txt format. That's not what you need. Not docx, not this as well. You need an in MD format, since that saves token in the cursors for the agent environment systems. Now I'm going to come to anti-gravity. Okay, and you will create an empty file, and you're going to probably name it like your team name, GCS version 1. You're going to name it version 1. This is your folder name. Inside your folder, you're going to have two things. First, my repo, Trishul.gcs. You're going to have my repo, the repo that I just gave to you. Go to my GitHub and you'll find the repo named by Trishul GCS. You're just going to clone that inside your GCS version 1. Let's say I'm going to catch a name from the chat section. Yeah, like Saris. Yeah, exactly. Software requirement specification is the same thing. Pavitra. How much time do we have? We do have some time. Okay, just let me wrap it up. So you'll say this is okay. You will have two files. First is my repo that you just clone, and second is the folder, or second is going to be the files and folders. So I'm just going to name anything like front end, and you're going to create another folder. You're going to name it backend. That's it. And then you are going to create another. You are just going to store the PRD file that you just created here as prd.md, and that's it. You have these files. Inside the empty folder, you have your software, the name of the software. This is inside this folder. You have my repo, you have your front end, you have your backend, and you have this MD. Or even just don't create this front end backend. Just have my repo and have this prd.md, and just open up anti-gravity and open up this folder and go to the prompts and say analyze this PRD, run and create an implementation plan. It's going to create an implementation plan by itself and build the software. It will tell you an implementation plan that what is specifically is going to build. And if it struggle at some point, you can just say that take logic and reference from where? From this repo, the Trishul GCS. Okay, take reference from Trishul. So it's just going to take reference. If anything that it lags upon, it's going to just take reference from how it works from there, and it's going to build you something like a GCS. That's it. Now, finally, if you have a working version, just go to Arduino, and then you are just going to paste the backend. First, you are going to go to ChatGPT or some kind of stuff like that. So you're going to ChatGPT, and you will paste your backend, and then you will ask for Arduino code or any microcontroller that you have. You are going to ask the code, dummy code to generate values at, let's say, 9600. So what you're going to do is, then you're going to open up Arduino, the programming IDE, and then you will just paste that code, and you will select your Arduino, you will upload that code, and then you will just plug in back. You will just close this IDE, you will plug in back, you will open your GCS, and you are going to connect the port, and you are going to test the software. If it works, great. If it doesn't work, then you have to understand. If it doesn't work, you just have to understand the basic of programming languages like Python, HTML, CSS, JS. That's it. That's all programming languages you need. And HTML and CSS is not even a programming language, so you probably going to need two more languages, and that's it. That will create a project. And finally, if you have a testing version, if you have a version that works, it works fine, then what you need to do is you need to just upload this code to the GitHub, to your own GitHub, so that you can have a stable version. You can have a stable version of the software. At any time, let's say you are trying to test something else, you're trying to test some other features. So what you're going to do is you're going to just let's say even if it did not work out, there is another way. It's not like you have to learn programming languages. What you need to do is just go again to the cloud, and then upload this 3 to 4 files, whatever you have the anti-gravity has created, and ask it where it went wrong, and then ask it to create another .md.instructions.md ask it to fix the changes step by step, and then upload this MD file in the same directory, and then ask the anti-gravity to follow that same thing. If you did not understand this process, you can just contact me after the session, and that is how basically you use the software. This if you understand the basics of Git, you can just read this PDF, you will understand it. It's simple to implement and understand, so don't worry about it. So I'm hoping for questions, and now I would request the host to at least either conclude the session, or maybe if there is time for question, so people can ask any kind of question. Don't worry, I'm going to send you the PPT.
So should we begin with the Q&A, or should I just end up the session since it's already time?
Okay, you can begin with the Q&A. We are just going to take a few questions, like 2 to 3 questions, and that will be it.
All right, sir. So all the participants who have a question, kindly raise your hand. Sir, we have a question from Sunidhi. Sunidhi, please unmute yourself. Sunidhi, please unmute yourself.
Good evening, sir. Good evening, ma'am. Am I audible?
Yeah, good evening. Yeah, you are audible.
So why we want our file in MD
What?
and not in TXT file? Why we want file from the cloud in MD1?
No, it's like it was just an example that you have to have an empty folder where you are trying to create your files, so you don't just integrate with some another software and some other files. Let's say you have your different project files, and the anti-gravity or the agent system is just going to consider that that's your different project work, and it will try to relate it to your own software, so that will be a problem for you. That's why I'm just saying that create a separate folder, do all the changes there, and try to create all of the files that are recommended to you. And the MD file is basically why you create to save the tokens. You don't want the anti-gravity to spend much tokens on understanding the TXT file, so you create MD file. Anyone else?
Is there any other participant who has any question? Please raise your hand if you have any question. So I guess there are no more doubts.
Okay, so conclude the session, please.
Thank you, sir. Thank you all the participants. Now you all can leave the meeting.